question. So like the first one, I've got 3x squared minus 12x plus 9. So if you can, before you start factoring anything, you should see if all the terms have a greatest common factor. And I didn't give you any questions like this on what we did yesterday, but these questions do have that. So I should probably just stop right before I do the problem. Just real quick, do 3, 12, and 9 have anything in common?
Yes.
What do they have in common?
The
3, right? They're all divisible by 3. Okay, so what I'm going to do, just real quick, and I know this has got 3 terms, and we didn't do any like this that had 3 terms, but this, I'm just undoing a distributive property, and I'm going to divide a 3 out in front. Then left over, I'd have x squared minus 4x plus 3. So then really what I need to factor instead of that original problem is just what I have in the parentheses. So in that question, I'm just looking at inside the parentheses, okay? My a value would just be 1 there. So remember we did yesterday, you have to multiply a times c, so this would just be 1 times 3. And I'm going to add to get the b value, which is just the number in front of the x. So can you think of, this one's really tricky. Can you think of 2 numbers, if you multiply them together, it would give you positive 3. But the same 2 numbers, if you added them together, you get negative 4. Three only has one set of factors, right? So 3, it's just 1 and 3. So it has to be 1 and 3. To get negative 4, I have to make both of those negative. So if I did negative 1 times negative 3, that is actually positive 3. Negative 1 plus negative 3, that would add up to negative 4. So that's how I want to break apart that middle term. The only difference between this and what we did yesterday, we're just going to have this 3 out in front. So I'd have x squared. Now, doesn't matter the order. I'm going to write minus x minus 3x plus 3. All right, so I just split apart that negative 4x into those 2 factors we just talked about. And then I'm going to do what we did yesterday, just a factor by grouping. I'm just going to draw kind of a line down the middle. So the only difference is we have this other 3 out in front. So I'm just going to ignore that for a second. What do x squared and x both have in common? X. Okay, so out of these first 2 terms, I'm going to pull an x. So we just have this 3 out in front. Then I would have x, and then in that little set of parentheses, we would just have x minus 1. If I divide x squared by x, it's still going to be an x left over. Negative x divided by x would just turn into negative 1. Okay, now the really tricky part of the second piece of that, if I factor these 2, that first term is negative. So I want that to be positive. So these terms, you got negative 3x and 3. Both of those numbers, let me grab a different color, are divisible by 3, but I want to take it out as a negative 3. Because if I do that, that'll make that first term positive, which is what you want in the parentheses. So I'm going to write minus 3, and then left over, this would first term would become positive x, that's what I want, and then 3 divided by negative 3 is negative 1. Okay, now, if you remember from yesterday, these guys match, so this is one of the factors, and then the other factor is just what you had on the outside. This is just a little weird because we had to take this 3 out in front to start the problem. So one of the factors is x minus 1, the other one is x minus 3. And that would be totally factored. We just had to take a greatest common factor out in front first. Let me just, go ahead.
Where did you get the x's from?
I'm going to skip the one in the middle, like the negative x and the negative. Okay, so these are the 2 numbers multiplied to give me 3, added to give me negative 4. So I used the, like this is the negative 1 and the negative 3 to break that middle term apart. So negative x minus 3x is still negative 4x, but when I break it apart, that allows me to do that factor by grouping where I can take a greatest common factor out between each of those sets.
So why is it written like that, like x minus 1?
So x minus 1 is one of your factors because they match, right? The other factor is whatever your greatest common factor, the x minus 3. You could put the x minus 3 first and the x minus 1 second. It doesn't matter either way.
Alright.
Yeah, these could typically if you do take out a greatest common factor, like we took out a 3, right, that would be out in front. And then the 2 factors next to it, those can come in any order. Let me do one more with you, and then I'm going to show you a little trick for this. Okay, these guys, I'm going to skip the one in the middle just for some space. So before I start to factor, just look at all the terms and see if they have anything in common. So do 5, 30, and 25 have anything in common that they could all be divided by? 5. Okay, so let's take a 5 out in front. All right, so this is really 5 times, we'd have x squared, 30 divided by 5, that would make that middle term 6x, and then 5 divided by 25 is 5. All right, so if I want to factor this, just like we were doing yesterday, I'm just going to kind of ignore the 5 that we pulled out in front and just focus on factoring what's in that little set of parentheses there. So for inside the parentheses, again, your a value is 1, your c value is 5, and your b value is 6. So I need to multiply a times c. So 1 times 5 is just 5. And I want to add to get the b value, which is just whatever the number is in front of the 6. Okay, now this particular one I think is tricky for people. Can you think of 2 numbers when you multiply them, you'd get 5. Same 2 numbers, you add them, you'd get 6. 5, it has to be 5 and 1. Some people can see the 6 and think 2 and 3. So this is 5 times 1, 5 plus 1 is 6. So there's only 2 numbers that'll fit both of those requirements. Those 2 numbers are what we're using to split apart that middle term. Okay, I tell you what, I'm just going to kind of ignore the parentheses for a second because I feel like that garbaged that up. So you bring down the x squared. 6x you're going to break apart into those 2 numbers you just told me. So one was 5x and one was just 1x. So I'm just going to write 5 and 1. And then you just bring down the plus 5. So those 2 numbers just help you break apart the middle term. And then I'm just going to lightly, like all this would be in parentheses with this 5 out in front because we had a greatest common factor to start. Okay, I'm just focusing on the inside. You're just going to split it right down the middle. What do the first 2 terms, x squared and 5x, have in common? And just an x. Okay, so I'm going to take an x out of both of these guys. And then left over, if you take an x out of x squared, you'd have 1x left. If I take an x out of 5x, I just have the plus 5 left. All right, now I think the other one's really weird here. What do x and 5 have in common?
1.
Nothing. So you take out a 1, right? They don't have, like, there's no x, whatever. So if you're thinking, okay, there's no number, there's no variable, then just take out a 1. So I'm going to divide both of these just by 1. So just write plus 1. Now, the leftover, it would literally just say x plus 5, but that's what we want because it matches the other parenthesis that we already have in front of that. So that's good. And then we just had this 5 out in front that we were looking at from the original problem. Okay, so my final answer then, we would have the 5 that we factored out in front. One of the factors, as you guys can see, the little parentheses that match here, you got your x plus 5, your x plus 5. So one of them's x plus 5. The other one is just whatever you pulled out. You have an x and you have a plus 1. So the other one is x plus 1. And that would be that one. Is anybody having a question? Now, I'm going to show you guys one more problem. This is not going to have a greatest common factor. So the main difference between most of the questions we're going to do today and what we did yesterday is my a value is going to be 1. Yesterday our a values were a bunch of different numbers. So here the a value is going to be 1. All right, so still the same rules. We're going to multiply a times c, and I need 2 numbers that'll give me that value that add to the b. All right, for this question, a is 1, b is 10, and c is 24. So in this case, if I do a times c, it's just 1 times 24. So I got to multiply to get 24 and add to get the number in the middle, which is just 10. Can anybody think of 2 numbers that you multiply them, you get 24, you add them, you get 10? And if you get stuck, I always just write down like any factor. So 24 has a lot. You got 1 and 24, 6 and 4 is what it is. I'm just going to write these real quick. If you get stuck, just write down any factors you can think of 24, and that'll usually help people. All right, so Zen says 6 and 4. 6 times 4 is 24. 6 plus 4 is 10. Okay, so I should have written this differently. All right, my original problem, I have x squared. Instead of writing 10x, I'm going to write plus 6x and plus 4x. I'm breaking apart that middle term, so we got 4 pieces, and then we can factor it, plus 24 here. All right, so I'm just going to split it down the middle, just like we were doing in the last problem. What do x squared and 6x have in common? X. Okay, so we're going to pull out an x. And left over, I would have x plus 6. What would you tell me 4 and 24 have in common? 4. So we're going to pull out a 4. So just write plus 4. And left over, again, I'd have x plus 6. So here's, these match. So that's one of my answer, or one of my factors, x plus 6. And then left over, we had the x and the plus 4, so that makes the other little set of parentheses. And you can put those in any order. What I want to point out to you, does anybody notice anything about our answer and what I asked you to get for the numbers to multiply and add? I have you guys look at those. This is a plus 6, and you told me 6 was one of the numbers. This is a plus 4, and the other number you told me was 4. So if you are just working where it starts with an x squared, you don't have to do that whole factor by group. I mean, you can if you want to, but you could literally just go to writing the parentheses, because you got x times x. If I FOIL that back out, that gives me the x squared. And then if you kept going, you would get that original problem. But if you don't have a number, like if you don't have a number in front of the x squared, that's, you know, if you have a 2, you can't do this. But if this just starts with an x squared, these two numbers will match what you have in the parentheses. So like if I'm doing a problem like, oh, this is a little different than the one at the top. So this one, I'm going to multiply 1 times 6, right? So I got to multiply to get 6, add to get 5. Can you think of two numbers, you multiply them at 6, you add them, it's 5?
1 and 6.
1 and 6 would multiply to give you 6, but that would add up to 7. So I got to think of a different option. 2 and 3. And the 5 and 6 one is always super tricky. Okay, now, instead of doing that whole process with factor by grouping, because this just started with the x squared, I could just go ahead and write, this is x plus 2, x plus 3. Just whatever the two numbers are, that'll be your two factors, and each of the beginning pieces will just be an x. If you're not sure, you can always FOIL this back out. Like if I do x times x, I get x squared. X times 3, 3x. 2 times x, 2x. 2 times 3, 6. This will give me back, when I combine like terms, the question I started with. So you can check that if you want, but maybe a little easier than yesterday. If it does not have an a, or if the a value is 1, the two numbers you tell me, those will just be the two numbers inside the parentheses with the x. So that might save you some time. If you like the factor by grouping, you want to keep doing that, you can. But if you like this better, you can just kind of use those two numbers to write your factors. So like this one, I'm going to multiply, a times c here would just be 1 times 16. So I'm going to multiply to get 16, add to get 8. And if this just starts with a plain x squared, I know to get x squared, I could multiply x times x. So I could just put those in my two factors. Can you think of two numbers, if you multiply them, it'd be 16, add them, you get 8? 4 and 4. 4 times 4 is 16, 4 plus 4 is 8. Now, these factors are identical. If you remember from yesterday, I'll take that as if you want to write that as your answer. But if they're exactly the same, you can squish them together and write an x plus 4 squared because you're multiplying it by itself. That only happens if the factors are exactly the same. Question?
So if you had like a negative 16, would one just be negative
9? That wouldn't work out for that problem. There's not going to be factors of negative 16 that would add up. Now, if that was a negative 8, instead of a positive 8, then it would just be x minus 4, x minus 4.
All right.
So not always if you just switch a sign is it factorable. It just depends on the question. I'm not going to give you anything that's not factorable here. So this guy, can you think of two numbers if you multiply them, you would get 10. You'd add them, you'd get 7. 5 and 2. Okay. 5 times 2 is 10. 5 plus 2 is 7. So if I do x, and it doesn't matter the order, x plus 5, x plus 2. I don't have to do that whole factor by grouping because I know x times x will give me x squared. 5 times 2 will give me 10. And that should take care of the middle part if you want to FOIL it out. This one is tricky. This last one I have here. I'm going to multiply to get 30, and I want to add to get 13. And I know if it just starts with an x squared, I know both of my factors just x and x, because to get x squared, I just multiply x by x. This is tricky because 30 has a lot of options. Anybody think of two numbers, you multiply them, you get 30, you add them, you get 13? What do you think? 10 and 3. Yep. So just make one of them a plus 3, one of them a plus 10. So it's really all about factors. And if you get tripped up, you can always write down factors of the number you want to multiply, and that usually helps people get there a little bit faster. Okay, now the second example, the a value is 1 on all of these. These are tricky though, because the way this is set up, the middle term is negative and the term on the end is positive. So these all have to have two negative factors. All right, so on this first one, I'm going to multiply to get positive 33, but I'm going to add to get negative 14. If you got to multiply to get a positive number, but add to get a negative number, both of the numbers you have to tell me, both factors, are going to be negative to make that happen. So to multiply to get a positive number, add to get a negative number. Can you guys think of two numbers, if you multiplied them, you get 33, but you add them, you get negative 14?
Negative 10, negative 3.
That'd give you 30. No, if you get tripped up, okay, 33. Let me think of numbers that multiply to get 33. I got 1 and 33, and we got 3 and 11. Those are really my only two options. 3 and 11. Okay, now to get the positive 33 but the negative 13, you would do negative 3 times negative 11. Negative 3 plus negative 11 would be the negative 14. So all you got to do in the parentheses, just write minus 3 minus 11. So if the number's negative, just when you write it in the parentheses, it's just going to be negative. If you did like the factor by grouping we were doing yesterday, you can do that. You would break apart that middle term into negative 3x, negative 11x. It might just take you a little bit more time because it ends up being the two numbers that you find to fit those requirements. If I do this guy, I'm going to multiply to get 12, add to get negative 7. Both of them have to be negative. Can you think of two numbers and multiply them, you get 12, add, you get, go ahead. Good. Okay, negative 3 times negative 4, positive 12. Negative 3 plus negative 4 is negative 7. So I'm just writing x minus 3, x minus 4. Honestly, it doesn't matter the order. If you want to put the x minus 4 first, the x minus 3 second, you can totally do that. All right, this guy, this is a little tricky. I'm going to multiply to get 81 and add to get negative 18. Yeah, this is 81 is 9 squared, but if I do negative 9 times negative 9, that'll give me positive 81. Negative 9 plus negative 9 is negative 18. So if I write my factors, it's just x minus 9, x minus 9. Or, if you want, they're exactly the same, so you can squish them together. Write that as x minus 9 squared. Okay, and then I got one more, and then we'll switch to a little bit different setup. Okay, this one I always think is super tricky. All right, so you got to multiply to get 1, but you got to add to get negative 2. Now multiply to get positive 1, add to get negative 2. Exactly. This one's really hard. So -1 times -1 is +1. -1 plus -1 is -2. So this would be x minus 1 times x minus 1, or actually it's similar to that last question. You can squish that together, x minus 1 squared, since they're both exactly the same. Okay, now the last type, this is what we have at the bottom here. And then I got a little special case, which is really easy. Okay, so if you have... Basically, this says the a value is 1, so these all just start with an x squared. And it doesn't matter what the b value is, but if the c value is less than 0, so that means your constant term is negative. If your constant term is negative, then you got to multiply to get a negative number. To do that, your lovely factors, you have to have one that's positive and one that's negative to make that happen. So sometimes these are a little bit tricky to get the right combination to fit the two requirements we've been working on. So for this one, I'm going to multiply to get -28, and I want to add to get 3. All right, again, if you get tripped up, I'm just going to write down your options. So 28, you got 1 and 28, 2 and 14, 4 and 7. So I somehow got to make a combination that would multiply to get -28, but add up to get 3. It's got to be the 4 and 7. Which one has to be positive? So I want to add up to have a positive 3.
Which one would be like positive? You said?
Yeah.
It would be 7.
Okay. Good. You'd have to use -4 and +7. -4 plus 7 will give you the positive 3. So when I say there's only one combination that'll work, there's only one combination. If you did like -7 and +4, that number in the middle would be -3. So got to think about it for a second. Okay, once you got those two numbers, just one of them's x minus 4, one of them's x plus 7. If it's a negative number, it's just subtraction in the little set of parentheses. If it's a positive number, you just go ahead and put a plus sign. All right, so this guy here, I got to multiply to get -30, add to get, I just have a negative x, so that would be a -1. So let me think of factors. 30 has a bunch of factors. So you got 1 and 30, 2 and 15, 3 and 10, 5 and 6. How can we get a combination that would multiply to get -30, add up to -1? What do I have to use there? Angela, what do you think? It's got to be 5 and 6. Okay, how would you write it? Like which one's got to be, let's say which one's got to be negative? Exactly. If you do -6 times 5, that's -30. -6 plus 5, that's your -1. So just one of the factors, x minus 6, the other one, x plus 5. Doesn't matter which one of those you write first or second. Okay, I got 2 more. We'll see if we can finish these up. All right, this one, I got to multiply to get -10, but I got to add to get +3. What two numbers would add to give you, or sorry, multiply to give you -10, but add to give you +3? Oh, he's stretching. I thought he was raising something. What do we think? So 10, let me think. You got 1 and 10 and 5 and 2. Those are your options. It's got to be 5 and 2. Which one's negative?
Have to be the 5. If not 3. No, 2, maybe 2.
Okay, the 2. All right, so if I do -2 times 5, you get -10, right? -2 plus 5, though, that is 3. So just when you write your factors, just do one of them's x minus 2, one of them's x plus 5. Doesn't matter if you can put the x plus 5 first, the x minus 2 second. That's totally fine. All right, I got one more. This one I think is really tricky. Okay, I got to multiply to get -11. And I need the same two numbers that would help me multiply to -11 to add to -10.
Yeah, 10 and 1.
That's not going to multiply to give you 11. You only got one option that multiplies to get 11. It's got to be 1 and 11. Okay, now, if I have to add up to negative 10, the bigger number has to be negative, right? So this would have to be negative 11 times positive 1. Negative 11 plus 1 is negative 10. So when I write my factors, just one of them is x minus 11. The other one is x plus 1. And you guys feel free to use your calculator on any of these. The key is, can you think of these factors and can you add them together? If that's tricky, then this can be really tricky. Okay, and at the very bottom, I promise this is easy. This is called a difference of squares. So you're going to see here an x squared and then just a number. And I don't know if you're familiar with these numbers, but I'm going to give you a formula and then I'm going to tell you another way to do it too. So the difference of squares, this says a squared minus b squared. This is the definition of this. This factors into a plus b times a minus b. And if you look at that, I had a squared and b squared in the problem. When I have just a plain a and a plain b, it's literally just the square root of each of the two terms. So like, if I had x squared minus 36, square root of x is x, square root of 36 is 6. So one of these would be like x plus 6, x minus 6. That's all it is. It's just the square root of each of the terms. Now, the other way you can think about it, if you want to think about how we've been doing it, multiply AC, add to B, right? This one would be multiply to get negative 25, but then since I don't have a B value, it would be add to get 0. Can you think of two numbers, if you multiplied them, you'd get negative 25, but you added them, you'd get 0? Like they'd cancel each other out?
0 and 25. 0 and negative 25. No, not.
I gotta have the numbers multiplied to get negative 25. What do you think? Yeah, it's just negative 5. Negative 5 times 5 is negative 25. Negative 5 plus 5 is 0. So it's just one of them would be x plus 5. One of them's x minus 5. So you could do it that way too. Or if you want to just go, oh, I know the square root of 49 is 7. Like this one would factor x plus 7, x minus 7. 144, if you know the square root, that's 12. One would be x plus 12. One would be x minus 12. So it's just the square root if you have it set up like that. Is anybody having a question?
I guess it's that one.
Yes.